Okay, so here's another example that we're going to do of solving a word problem. So again, listen carefully. It says the electrical resistance of a length of wire is equal to the resistivity of the metal times the length of the wire divided by the square of the wire diameter. Okay, so let's take this piece by piece. Okay, so it says the electrical resistance of the length of the wire. So what is that? That's resistance, right? So they're just basically talking about resistance. So let's denote that as R. Okay, so they're saying that this resistance is what? Is equal to, okay, well let's put the equals. Okay. Now is equal to what? Equal to the resistivity of the metal. Well, so it's equal to the resistivity, right? So resistivity times the length of the wire. So the length. So we can look at this as resistance is equal to the resistivity times length. Okay, so let's do resistivity as lowercase r. Resistivity of the metal, right? That's how the metal has properties that makes it more or less resistant to, let's say, the flow of electricity. Okay? Okay, so R is the resistance, right, is equal to the resistivity of the metal times the length, right, lowercase l, we'll just use lowercase l. You could use capital L. Okay, so it's resistivity times the length divided by what? The square of the wire diameter. So it's basically diameter, right? So it's divided by the square of the diameter. So divided by the square of the diameter. And there we have it. That's the formula. So let's just rewrite this a little bit. And that's it. Okay. Okay, let's do another one. Here's another example. It says a total of 66 cubic yards of concrete is required for a pour. Okay, so we need a total of 66 cubic yards of concrete. So 66 cubic yards of concrete is needed. Okay, for a pour. The combined amounts of cement, sand, and gravel is to be 1/2 times the amount of concrete needed. Okay, so let's read that again. The combined amounts of cement, sand, and gravel should be 1/2 times the amount of concrete needed. Okay, so the amount of cement, sand, and gravel, okay? Cement, sand, and gravel should be what? 1/2 times the amount of what? Concrete needed. Okay? So that's that part. Now it says, for this particular job, cement, sand, and gravel must be combined in the ratio 1 to 2 to 3. So it should be 1 to 2 to 3, which should be the ratios, right? Okay, so 3 parts gravel for each part cement, right? 2 parts sand for every 2 parts cement, right? So those are the ratios. Okay? What volume of each component is necessary? Okay, so the first thing is, let's take this in pieces, right? So the first thing is we're given, this is the total amount of concrete needed. Okay? The amount of cement, sand, and gravel together should be 1.5 times the amount of concrete needed for the job. Okay, so if we need 66 yards of concrete, then guess what? We're going to need how much of this material? 1.5 times that. So the amount that we're going to need, so the amount of cement, sand, and gravel is equal to 1.5 times the amount of concrete needed for the job, which is 66 yards, 66 cubic yards. So that means, what are we going to have? We're going to need 99 cubic yards of what? Cement, sand, and gravel. Okay, now, again, what's the question we need to answer? Always remember what the goal is. We want to know what is the volume of each component that we need. Okay, so now here's the thing. So this 99 cubic yards consists of all of cement, sand, and gravel. So what they want to know is how much volume of cement do we need? How much volume of sand do we need? And how much volume of gravel do we need to make up the 99 yards, cubic yards? That's the answer to the question, okay? Or that's the question we need the answer. Okay, so now, well, we're going to use the ratio, 1 to 2 to 3. Okay? So how do we use that? Well, first of all, we know that the volume of cement, sand, and gravel have to add up to 99. So the volume of cement, so I'll use S for the volume of cement, or you know what, let's do it differently. Let's do V sub S for the volume of cement plus what? Not cement. C for cement. And so plus the volume of S, which is the volume of cement, or excuse me, sand, plus the volume of gravel, right? All of those volumes have to equal 99 cubic yards. Okay, great. Now, these ratios must also be included, which means that we should have twice as much sand as cement. And we should have 3 times as much gravel. So this ratio 1, 2, 3 tells us that, hey, if we put everything in terms of the volume of cement, right, then what we can do is, this is V sub C plus, well, if I have V sub C, how much sand do I need? Well, I need 2 times the volume of cement. And if I look at the amount of gravel I need in relationship to the amount of cement, I need 3 times as much. I need 3 times as much. So the amount of gravel is going to be 3 times the volume of cement. equals 99. Now you could use X, you could use XY, you could use XYZ if you wanted. That it's fine, I'm just using different variables. Okay? Now the thing is I was able to use this information to substitute in for V sub S and V sub G so that I have one variable. Now I can add these up and I get 6 V sub C is equal to 99, and now I can solve for the volume of cement. Okay, and now what is my volume of cement going to be? My volume of cement is going to be what? 11. Oh, hold on. No, not 11. It's going to be so 33 divided by 2 is 16 and a half. So the volume of cement I'm going to need is 16 and a half cubic yards. Which now means that, guess what? The volume of sand is going to be double that, which is going to be what? 33 cubic yards. And then the volume of gravel is going to be double or triple that. So that's going to be what? 49 and a half cubic yards. And now I'm going to check this. How would you check this to make sure you didn't make a mistake? Well, all these volumes should add up to 99. Well, 49 and a half and 16 and a half equals 66. Plus 33 is 99. And so it adds up, okay? And we're done. So it makes sense. And so that's the answer. So again, it all stems from making sure that you read the problems carefully. Okay? Have a great day.